All right, we're going to continue on in the subject of aircraft fuel systems. Moving into the fuel quantity indicators. Okay, all seems well. There's a variety. Usually there's four main areas of fuel quantity indicators. The most elementary is the one that we're looking at on the screen now, the direct reading sight glass. You can see there's a sight glass extended into the fuel tank, which you can actually see the same level that is in the fuel tank that way. It's a transparent tube connected between the top and the bottom of the fuel tank, so you're getting the pressure from both sides. You're not creating a little vacuum there. There's a word I think it may have copied incorrectly. I'm not familiar with that word for the space in the fuel tank that is not occupied by the fuel. Part of the direct reading is a mechanical. Instead of having it directly like the sight glass, you actually have a float in the fuel cell, and that is connected to an indicator by a mechanical operation. You can see there's a pinion gear and a main gear. As the float raises, you can see that it would actually pull the crank down, and that would actually move the pointer. Okay. The electrical types, they basically operate on an electrical resistance theory. So basically you have a variable resistor, and depending on where the float is located, the float is in effect adjusting your variable resistor, so giving it more or less resistance. And of course that can be shown on an indicator. So the float with the resistance element is the tank portion, and then wires are connected to the indicator itself. These systems use a sender or a transmitter that consists of the variable resistor mounted on the outside of the fuel tank, operated by an arm connected to the float that rides on the surface of the fuel in the tank. So there's a little wiper on the resistor, which is actually moved. The one that's shown is a ratiometer. There's actually two different types. The ratiometer has a magnet as an indicator between two coils of wire, which, depending on the resistance, is going to give more of a electrical magnetic field to attract the magnet or not. So yeah, you can see if it's empty, it's going to pull the magnet towards the empty on the indicator. The type for the larger aircraft is a capacitance. In theory, it's like a big capacitor where you actually have two plates separated by a dielectric. Well, let's see what they say about this. There's no moving parts, so that's an advantage. It's more accurate than other types of systems used for measuring fuel quantity. There's several of these installed in the fuel cells or the fuel tanks, and some in the front, some in the back, some in the middle, and they extend from top to bottom. And in effect, you're able to measure fuel quantities based on the fuel that's on the outside, or actually in this case, I believe it would be on the inside of this outer housing anyway. Fuel or air. So basically that's how the capacitors work. Let's see, I probably have more details. All right, so what are the 4 general types of fuel quantity gauges? So we looked at the 4. And of course the answers are 4 options. So what did we already look at? Well, we certainly didn't look at a litmus indicator. So you can take off C. 8 was a direct reading static pressure type. Direct reading I like, but static pressure I don't. All right, so 1 definitely was on the list, sight glass. 2, mechanical. I guess that's another form of direct reading, but which is not a sight glass. 3, electrical. 4, electronic. Well, I like the first 4. So A. I'm not sure if the actual test is going to mix up the list of 8. I presume they're not. So if you do see that, it does seem like the first 4 are the correct answer, or is the correct answer. All right, this time they're not going to give you the list. They're just going to ask you name 4 types of fuel quantity gauges currently in use. If you did it in order, you'd probably list the sight gauge, the mechanical gauge, the electrical gauge, and the electronic or capacitance type gauge. Sight, mechanical, electric, and electronic. I think we got it verbatim. Calibration. Fuel gauges and transmitters should be calibrated to indicate empty when the system has no more usable fuel in it. So you don't want the pilot to have to say, "Well, I recognize this aircraft," and like with your cars, some people really push driving on empty because they know they can get another 10 miles. Well, when you're in the air, that is let's have that a little more consistent. And so basically, it's going to read empty, which would be 0 in this case. This is below empty, so it's probably if it's an electrical one, the system hasn't been turned on. But in this case, 0 would indicate that there's no more usable fuel in it. There might be actual fuel in the fuel lines, or maybe at a part of the tank that is not used. And we could see it is a Part 23 requirement. So first of all, there must be means to indicate to the flight crew members the quantity of usable fuel in each tank during flight. An indicator calibrated in appropriate units and clearly marked to indicate those units must be used. And you can see the 0 requirement in Part 1. Calibrated to 0. And the question is, what must each fuel quantity indicator be calibrated to read during level flight when the quantity of fuel remaining is equal to the unusable fuel supply? Well, there you go. It's almost verbatim with the regulation. And if the fuel remaining is equal to unusable fuel supply, it should read 0. Of course, we wouldn't want to be in level flight at that point. But 0 is the correct answer. According to part 23. Okay, here is a little more detail of the capacitance type, the electronic type of fuel quantity indicator, mostly used in larger transport category aircraft with large tanks. And there may be a dozen or more in each tank. Here's a schematic of one. What is this basically? Well, let's come back to it. The components in the fuel quantity indicating system are the probes themselves, and we could see the probes. They're actually showing an image of a probe, the tank unit capacitor. And if you go into it a little deeper, there is a compensating capacitor that goes with it. But let's just say the tank unit. Capacitor probes mounted in the tank. A bridge circuit to measure the capacitance of the probes. Now that's kind of what this is over here. That's a bridge circuit. You can see the power coming in 115 volts at 400 hertz, our standard AC that we use, and that is set across something that looks like a transformer with a center tap on it. 3, an amplifier to increase the amplitude of the signal from the bridge circuit to a value high enough to drive the indicator. All right, so where would I see an amplifier here? Okay, here it is in the brown. And finally, an indicator mounted in the instrument panel to show the amount of fuel in the tanks. So the indicator is the round instrument with the arrow. And I would presume that's what the question is going to look like. You can see in the block diagram here, the bridge circuit, the amplifier. Do we remember the other two? The probes and the indicator. All right, let's see if we can power through this next question. Which doesn't look like it totally applies, but let's go ahead with it. Which aircraft fuel quantity indicating system incorporates a signal amplifier? Well, right there, I don't think you have to know all the components. An amplifier is an electronic type component, so I'd be real surprised if the other options could come any closer. It certainly is not part of the sight glass, and it is not part of the electrical, so it is electronic. So, drifting off screen. All right, it's got to get a little tougher than that. Okay, here we go. Electronic components. The electronic type fuel quantity indicating system consists of a bridge circuit, and then what else? Well, we saw the amplifier even in the last question. So I like A already. The indicator in the tank unit, that basically rounds off the 4 that we looked at. The other ones have a tank in it, and I suppose that's going to throw. I mean, a tank is part of the fuel system, but it's not a part of the fuel quantity indicating system. So the tank doesn't belong, so B and C are incorrect. So A is the correct answer. And the answer goes forward and mentions the 4 items again. All right, here's a nice little illustration of the probes that are in the, looks like the fuselage tank. Maybe it's part of the wing root also, but the fuel probes are included. It doesn't show them in the wing fuel tanks on the far wing, but it does show 1, 2, 3, 4, 5, 6 probes, and it also looks like there's 3 fuel pumps. Okay, so they typically do use the electronic fuel quantity systems. They're more costly systems, although we've got them in the hangar. So if you go and handle them, it doesn't seem like they're a costly unit. They seem to be of some sort of composite material, which, most items that are plastic can usually be mass produced at a fairly reasonable rate. But of course, with aviation, that does not translate. They do have the advantage of having no moving parts in the actual sending unit. There might be some moving parts further down the line, particularly maybe the indicator. Variable capacitance transmitters are installed in the fuel tanks, extending from the top to the bottom of each tank in the usable fuel. So if basically the tank is full, it's going to be, the probes are going to read all fuel or liquid. And if the tanks are empty, the probes are going to read air or no fuel. They are wired in parallel, which basically by doing that, they're able to show you an overall level. Because during a bank, the ones on the left might be fuller than the portion of the tank on the right. So by being in parallel, they're able to kind of balance that off. Which statement concerning an electronic capacitance type fuel quantity indicating system is true? A, it has no moving parts in the tank. Now, right there, that's one of the key points. B, it has 2 tubes separated by an electronic field in the tank. That is not correct. It's 2 tubes, one inside each other. So there's some truth to that, but it's not true enough. C, it utilizes a variable capacitor to indicate the fuel tank capacity. That's not a terrible answer either. But I'm going to go with A. It has no moving parts because that's the main item they want you to cover. But you look into it much deeper, and those other 2 answers should be just a little further from the truth. These probes are made of 2 concentric tubes that serve as the plates of a capacitor. Okay. Yeah. Well, it has no moving parts. That's the official answer, and it has not been disputed. If there's a dispute between any of the publishers, I'll bring it to your attention. What type of remote reading fuel quantity indicating system has several probes installed in each fuel tank? All right, you can see a theme going here. So what has several probes, that's going to be the electronic. We'll jump right to it. It's certainly not the direct reading or an electromechanical type. It's probably the most advanced of the three. Electronic. Okay, a little more closer discussion of a capacitor. You can see there's two electric, in effect, plates, but they're actually going to be cylinders, concentric cylinders. And let's see, you may have already learned that a capacitor is a device that stores electricity. The amount it can store depends on three factors: the area or the size of the surface area of the plates themselves, and the dielectric constant of the material that's separating the plates. So the air or the fuel that's going to be in between these two plates would be the dielectric material. Fuel tank unit contains two concentric plates that are a fixed distance apart. Therefore, the capacitance of the unit can change if the dielectric constant of the material separating the plates varies. Okay, another way of saying what we've been discussing. A probe or a series of probes is used in what kind of fuel quantity indicating system? They love this question. This time they're not going to give you the electronic as an answer. It's going to be Selson, capacitor, or synchro. Now, since we've looked at the electronics of it so closely, we're going to know it's the electronic component known as a capacitor. It's not the traditional capacitor that you might use in a circuit. But it uses the same concept. Then there's actually a very slight charge going between the two plates. Certainly in a fuel which in effect goes through the fuel. So it's certainly such a minute amount, though it's not going to create a hazard. But the answer is capacitor. Two plates separated by a dielectric is the concept. In an electronic type fuel quantity indicating system, a tank sensing unit is all right, here we go. We got capacitor. We like that already. Or a variable resistor. I like the word variable, but now with resistor. And our other component, an inductor, which are basic three electronic components. Start getting into diodes also, but of those three, capacitor is the correct answer. And that's the tank sensing unit, the probes. We mentioned dielectric is partially air and partially fuel, and if you study that into some level, the difference is going to be that when the tank is empty, the plates are separated by air, and air has a dielectric constant of 1. But when the tank is fuel, the dielectric is fuel, and that has a dielectric constant of approximately 2. So if it's halfway filled, the capacitor is going to read 1.5, and so it's going to show that on the indicator that there's the fuel the quantity is half there. The tank is half filled, and that's a level. No, strike that. Any condition between full and empty, part of the dielectric is air, part is fuel, so the capacitance of the probe varies according to the level of the fuel in the tank. What is the dielectric, the non-conducting material, in a capacitance type fuel quantity indicating system? Um, is that the outer shell of the capacitor? Is it the fuel in the tank? Or is it the fuel and the air in the tank? So don't jump on fuel in the tank, because fuel is only half of the equation. The other half is the air. So the fuel and the air in the tank is the dielectric. They do indicate that a dielectric is a non-conducting material. In most of the electronic capacitors, the two plates are separated by an insulating type thin material like mica. So technically the dielectric is non-conducting, same as air and fuel. The question reworded, so either one could pop up. We saw that one. Let's see what this one is. The probe of a capacitance type fuel level gauge is essentially an capacitance type, so we know it's going to be electronic. So it's not a float actuated. It is B or C, a capacitor. B, capacitor with fuel and air acting as one plate? No. Or C, capacitor with fuel and air acting as the dielectric, which is the correct answer to the same question, in effect reworded. And I believe I've got another presentation that covers these even further. So they definitely want to quiz you in fuel systems on it. And other than this, there's not a lot of coverage of this type of. There's a project that you'll be tasked with on fuel quantity indicating systems, but it's not otherwise a big part of the lectures. Do have a fairly short review video, and hopefully I can make these available. So far, that's not going. I'll see what I can do down the road. Some supplemental materials. Let's take a quick look at them. All right, here's indication. Let's see if these were two wires and it comes to two plates. This one has a wide separation between the plates, so it's going to not have a very strong field. It's going to be a weak electrostatic field, and so therefore it does not have a very large capacity for carrying much of a charge. As opposed to a close separation, the field is stronger and it's got a larger capacity for the size of its capacitance. This I thought was an early attempt at a GIF file. Not really showing it, but this is an experiment we like to do in the class, where basically we'll in effect charge the capacitor, and the light will go on shortly, and then basically we disconnect it. Does it say how it does it? The circuit will flash the LED once the circuit is first connected. Okay, then you basically remove the two probes from the battery, but if there's a charge in the capacitor, you can just connect the two to each other and you'll get a short little burst from your LED. To illustrate how a capacitor can hold a charge. It's not like a battery, where this one, it basically builds up and releases. The systems typically used to monitor fuel quantity on large aircraft don't have moving parts in the tank, but rather use several of these devices to electrically measure fuel. So we're going to be looking for the probe types. Here we go, variable capacitance transmitters. That's the best answer. The variable resistance and ratiometers are pretty much the same things, and that's does have moving parts in the tank, and as does the float. The float itself is the moving part. So A. Here's the schematics for your variable type of capacitors. Here's a fixed capacitor and a variable capacitor all the way on the right. You may not see this one in the middle too often, but basically it's polarized, so one of the plates must be used on the positive side of the circuit. Otherwise, the other two are pretty much, you can flip them upside down. The polarity doesn't matter. One advantage of using a capacitance type fuel quantity indicating system is that this system, what would be an advantage? It's no moving parts, a little more reliable. A, is not affected by changes in fuel temperature. Not so sure about that. B, indicates the fuel quantity in gallons rather than pounds. No, it doesn't. It would kind of be the opposite, actually, pounds instead of gallons. C, it senses the density of the fuel as well as its quantity. I don't hate the answer. That I don't know. I'm going to go with C, just because I'm not totally sure that fuel temperature doesn't have some impact in addition to the capacitance itself. So C, yes. I may have dug these newer questions out of I strike that. I'm not exactly sure where this question came from. I've got a list, but I don't have that out in front of me. Probably should. We looked at a bridge circuit briefly earlier. And, okay, here's another illustration. You can see the bridge circuit was the regular AC power coming in on one side, and then what looked like a transformer and a center tapped on the other side. The bridge circuit, and then it goes to a amplifier somewhere along here, which isn't being shown. It does, I guess I want to point out that there is a reference capacitor that is actually being used to tell the difference between this side and the capacitor that's actually in the fuel. And it compares the two, and then that you can see that they're actually both tapped into the indicator. So there is the difference, I guess, when voltage is induced into the bridge on this side. Capacitive reactance of the tank probes and the reference capacitor can be equal or different. The magnitude of the difference is translated into an indication of the fuel quantity in the tank, calibrated in pounds. All right, this is supplemental material. We're going into it a little deeper, mostly because we've still got a little bit of time for this session. But let's see if there's a question that would actually ask about the reference capacitor for a bridge circuit. A compensator unit, now those you will actually come across, and it's kind of nice to know what one is. It almost looks like a small probe. It's mounted low in the tank, so it's always covered with fuel, and it's wired into the bridge circuit. So basically, it's kind of the opposite of the reference capacitor, which appears to be in air, as opposed to the compensator unit, which is in effect another capacitor that's in the water. And so it doesn't say it's a capacitor though, so I might be presuming that. It's always covered with fuel. It modifies current flow to reflect temperature variations of the fuel, which affect fuel density and thus capacitance of the tank units. Yes, that's what I was going to mention earlier when we were talking about that one option. It's not affected by changes in fuel temperature. It is the capacitance electronic type is affected by changes in fuel temperature, unless you have this compensating unit to compensate for the change. And that's what this is, a compensator unit for fuel temperature. Which is why it's immersed in the fuel. All right, that's it. All right, that was great. Unfortunately, I got one more that looks a lot like that. So we'll call it part 2. So thanks for joining me for part 1. So let's see if we can fly through part 2 while we're thinking about this topic. So, all right, I'll see you then.